So here's the next problem. So we have a triangle ABC where BC is greater than AB. I think we want AC. Whoops, sorry. I'm trying to figure out how we want the diagram to look. Do we want AC to be on the bottom? I think we want, yeah, it's hard to decide which side should be on the bottom. I think we want B to be on the top. All right. So D lies on AC such that ABD is equal to CBD. Okay, so they're isogonal. So here's often how I would do that. Oh no, it's angle bisector. Whoops. So ABD is equal to CBD. And then, actually, you know what? I'm going to leave the whole line there for now. And then probably erase part of it later. But so AQ is perpendicular to BD, and CP is perpendicular to BD. Okay, so I'll call these P and Q. M and E are the midpoints of AC and BD, or AC and BC. So that's E. I want to call that M. Circle O is the circle.
Wait, it's AC, right? Not AB.
Oh yeah, you're right. So good call. So O is the circumcircle of PQM. I think, let's see. Did I do all that right? Oh, this should be Q and that should be P, right? AQ, yeah. AQ and CP. And it intersects side AC at H. And we want to show OHEM are cyclic. O is the center of C. Okay, there we go. All right. Something like that. I'm going to hide some stuff just to make it look nicer. All right. So let me check that the problem is true. OHEM. They are indeed cyclic. So yeah, there's a couple ways. Like I could take the circumcircle of OHM and I could let it intersect the side at E and at E prime, and I could show E prime as the midpoint, something like that. Are HQ and E collinear? Let's see. I don't think so. Oh no, it's all right. But basically, if they were cyclic, O would be the midpoint of arc HM, right? Because OH is equal to OM. Yeah. Yeah, how do we want to go about this? If we could show, so if we can show OE is the angle bisector of HEM, does that solve it? Let's see. All right. So EM is parallel to AB, right? Is AH perpendicular to AC, or is, I think BH might be perpendicular to AC. So maybe they kind of gave that away by calling it H, because H is sometimes the foot of the altitude, but I think BH is perpendicular to AC. How would we prove that? And yeah, that would mean BAHQ would be cyclic. Is that an angle chase? Yeah, I think that is an angle chase. Are PM and E collinear? I think they might be. It sure looks like it. Yeah. Let's see. So that is that would mean AB is parallel to PM. And if we know that this is cyclic, yeah, so I'm trying to think of what is the best way to go about this? Can we show ABQH is cyclic? I think so, because angle HQP is HMP is EMC is, yeah, okay. So we know PM and E are collinear. I can prove that. Actually, hold on a sec. I'm not sure I can prove that. Let's see. So yeah, let me delete this circle just so that I don't already see it. But first we want to show BAHQ is cyclic. So yeah, so angle HQM, QHM is QPM. See. For angle HQP is HMP. Yeah, there's got to be. Yeah, how do we prove PM and E are collinear, or equivalently BAHQ is cyclic? Maybe power of a point. So we want to show DH times DA is DQ times DB. So is, yeah, that would just be ratios. Can we show AD over BD is DP over DM? That would get us there too. Yeah, there's a lot of equivalent ways of looking at this. And we know, since Q is the midpoint, well, oh yeah, it's not necessarily, Q is not necessarily the midpoint of our HM. Yeah, so okay, so yeah, I think so. dA over dM is dA over half of AC. And dQ over dP I think I have a couple ideas here. Let me draw the circumcircle of ABC. But yeah, let me write out some ratios here. So yeah, I'm trying to show basically PM and E are collinear. BD, QP are in harmonic conjugation. I think that would help. I'm trying to see. How did you arrive at that?
Yeah, so if you draw the perpendicular to BD through B, then you get like this harmonic, these harmonic conjugates, right, over line AC.
So
and then you look at point D and you just project them.
You're just projecting them all onto BP.
Yeah.
So those are in harmonic conjugation. Okay. That means that D lies on the polar of B. I'm not sure how much that helps. Yeah, interesting. I'll keep thinking about that. But yeah, so I wanted to show PM and E are collinear. That's the same as saying that DM over DA is equal to DP over BD. And that seems like it could just be doing a bunch of ratios, right? So let's see. So we have AD over CD is equal to DQ over DP. And we also have that's equal to AB over BC. Yeah, what was I trying to do here? Oh, I think if we can show AP over AM is equal to BD over AD, that would solve it. Let me write out these ratios. I'm just going to write it out on paper here, and then see. CO2. Okay. Oh, whoops, I did this all wrong. So hold on just a second. So I'm just writing out some ratios on some scratch paper. Q times All right, let's see. Getting a little confused here. But yeah, I know this is doable. Yeah, there's just so many ways of thinking about it. That's a tricky thing. Yeah, if we can show PM and E are collinear, I think we're really close to solving it. And that looks like bashing. I wonder if there's a better way to show it than just bashing with ratios. So so if B, Q, D, and P are harmonic, we can draw the parallels to A, B, and ME, right? And so, let's see. Maybe we can project through M. Is BQMC cyclic? No. Let's see. Okay, I'm going to go back to my ratio strategy. BD. Let's see. BP over A.
I wonder if M is the midpoint of arc QP, because it does seem like, and uh, I'm getting some deductions to it. I was saying PQM is a isosceles triangle, maybe. If you could rotate the figure, we'll see it.
Yes, it looks true. So yeah, PQM looks isosceles. I think I might have an idea on how to prove that. I'm not sure. That's kind of the same as, is that the same as saying QDM is isosceles? I'm not sure. No. PQM is isosceles. If we can prove MQ.
Oh, actually, it is isosceles because triangle MAQ is congruent to triangle MPC.
Is that true? MAQ is congruent to MPC?
Yeah, because the parallel line is there, and since M is the midpoint, so we have AM equals to CM.
So AM is equal to CM.
Yeah, and AQ is parallel to PC.
And AQ is parallel to CP, but CP isn't equal to AQ. CP is bigger than AQ, right?
Yeah.
If we can prove MQ passes through the midpoint of AB, then we can project. Hold on a sec. Yeah, I'm still writing out these ratios on my paper. BP over AM. It seems like it should be provable that BP over AM is BD over AB. Seems like that has to be provable. Yeah. So yeah, those 4 points are in harmonic conjugation. I mean, since if they're in harmonic conjugation, then that means that BQ or I'm trying to think the best way to say it, but that means that DP over BP is equal to QD over BQ. So we want to show QD over BQ is equal to AD over DM. Let's see, BQ. Yeah, I think the fact that they're in harmonic conjugation is useful. Trying to figure out how to use it. Let's see. Yeah, I don't know why I'm having so much trouble with these ratios, but it seems like it felt like it should just be a ratio bash. So ABQ is similar to ACP, right? And AQD is similar to CDP. So Let's see. I keep saying let's see. Yeah. Are PO and H collinear? Let's see. I would be surprised, but it looks like PO and AQ concur on the circle. It's kind of interesting because that means angle. Well, yeah, PO and AQ do concur on the circle because angle AQP is 90 degrees. Maybe that helps. I don't know. But if Q, let's see. Yeah, I'm still writing out these ratios. C over AC. Okay, let's see. BD over AD. How do I get that? I think I have what were you asking? Because then we know how HOM. Oh, I missed the, yeah, if okay, you're asking if we can prove PME are collinear, then angle chasing finishes it. Yeah, I think so. Yeah, I'm just having trouble with it. Hold on 1 second, guys. I'll be right back. All right, thanks for waiting. Yeah, I'll spend like 10 more minutes on this and then I'll switch to the next one if we can't figure it out. So angle PMH, you want to show as EMC, but PMH is PQH. Yeah, I'm kind of going in circles here. Okay, I think I might have an idea. Let's see. And then BQ. Okay. D over AD. All right. So that's just doing a little scratch work here. Is B over CD. BP over AM. That's all right. BP minus BQ. So I'll write out what I've found so far. So kind of messy, but let me move the diagram a little bit. Make room. So BD over AB is equal to BQ plus QD over AD, which is equal to BP times AB over AC plus QD over AD, which is equal to okay, so that's PEC is twice PBE. I think that does it. That was very silly of us to make it that hard. Okay. So the solution is actually quite simple. We were just overthinking it. Okay. So angle PBC is 90 and M is the midpoint of BC. Okay. And so actually before that, all right, so we know ME is parallel to AB. Because it's a mid segment. And so angle MEC is equal to angle ABC. Yeah, sometimes I just get stuck, you know, and I just can't figure out that stuff. Oh, I need the backslash. Okay. And then since PBC is 90 and M is the midpoint, or E is the midpoint of BC, I should say. So that means angle PEC. PEC is equal to twice angle PBC is equal to angle ABC. And so P, M, and E are collinear. So I'm going to finish in a half hour, just to let you all know. So maybe one more problem after this. Whoops. So P, M, and E are collinear. And once we know that, then I'm going to finish the way Hakan said. So then we know angle HOM. How do we know that? But anyways, once we know that, we can prove BAHQ is cyclic. Yeah, how do we know HOM? Because then we know HOM and BEM. Because MQD is equal to CBD. How do we know that? Okay, so what's the best way to show HOME is cyclic? We could try to show angle EMH. I'm going to say EMH is equal to EOH. So first, suppose that let's see. Aren't MQ and BC parallel by symmetry? What's the symmetry? They look parallel.
Yeah, like same way, like if PM passes through the midpoint of AC, then like by symmetry, MQ should pass through the midpoint of AB.
Oh, so by a symmetric argument.
Yes, yes.
Okay. So let's see. Okay, so MQ is parallel to BC. And then how does that finish it? How does that finish the problem? I forget. Or Hakan was saying we're done. I forget how. Wait, he said because MQD is equal to help me out. Finish off. How do you do the angle chase that finishes it? Okay, so that's HOM. I agree with that. HQD plus. And how do HQD is equal to BAC? Is that, do we need to know BAHQ is cyclic for that? I can prove it, but I wonder if there's like I'll just start typing it up. So HOM is equal to 2 times 180 minus angle HQM. This is equal to 2 times 180 minus angle HQD minus angle MQD. And that's 2 times 180 minus angle CBD. And then HEM okay, let me write this out so far. So you start out like this, right? So HQD is HMP. Okay, I think I got it. So that's equal to angle BDA. Is that right? And let me just check that. Where's my measurement? So angle HOM is 135.6. BDA is 67. That looks double, I think. 67 point, yeah. Okay. And then HEM, you're saying we can calculate. Let me check the chat. HEM is BEM minus BH. and BEM, BEH is twice BCA. But that's assuming, yeah, so I was wondering if we could do the proof avoiding that BH is perpendicular to AC, but I'm not sure now. So is it obvious that BH is perpendicular to AC, or do we need an angle chase or something?
Yes, pH is perpendicular to AC.
How do you prove that?
I think, yeah, it occurred to me, but just one minute.
Since MP is parallel to AB, MPQ equals CAB. Okay. Yeah, I guess it's just kind of a lot of steps, but I thought this problem might be a little shorter, but I'll write it out. So okay. And so HOM we said was 2 BDA, and HEM is BEM minus BEH. So yeah, what was angle BEH? I forget. BEH is 2 BCA. Okay, so because so all right. So BHC is 90 degrees. So BEH is twice angle BCH. Okay, so and BAC it's ABC. Yeah, ABC. You're right. Okay. So we want to show ABC plus 2 BCH is 2 BDA. And that's true. Yeah. So Okay, so all right. But so if we look at this triangle BDC, you have DBC, BCH. Basically, that is, I mean, these two together imply angle HOM is 180 minus angle MHQ, or I'm sorry, angle HEM. And that implies HOME is cyclic. Which solves the problem. All right, so that was, maybe I made it a little harder than it had to be. But let's see if we can make progress on one more problem here. So thanks everyone for your help in that. Oh, this one looks kind of interesting. All right, so we have a triangle ABC. We draw the median AD, and then K is the midpoint of that. And then DE is perpendicular to AB, and DF is perpendicular to AC. Okay. KE and KF. Okay, we want to see where KE and KF intersect BC. So M and N. Let's call it M and N. And then we draw the circumcircles of DEM and DFN. Or did I do KE? Yeah, I think that's right. Did I do this right? Let's see. Okay, so we have the two centers of those circles. So O1 is the center of C. Okay. I want to do that. GeoGebra is being difficult here. O1 is equal to the center of C. There we go. And O2 is equal to the center of D. We want to show O1, O2 is parallel to BC. Let me hide some stuff. Okay. All right, which is the same. It's the same as showing that like if we draw the circumcenter of ABC, that's the same as showing it lies on the radical axis of those two circles. What is this thing? I want to get rid of this thing. There we go. Okay. So we have a median, K is the midpoint. Two perpendiculars here. So DEAF is also cyclic with center K. Let me draw that in. So is there another way we can restate this? So the distance from O1 to BC is the same as the distance from O2 to BC. That means, I think it means like MO1 and NO2, if we can show they pass through that point, then we're good, right? That other intersection point. So yeah, I mean, that's the same as saying MDG is 90. KO1 looks parallel to AB. It does look parallel. And KO2, interesting. So so that would be the same as saying KO1 is perpendicular to ED. Yeah, that's true because K and O1 are the centers of the circle, so KO1 is perpendicular to DE, and so KO1 has to be parallel to AB. Okay. We want to show O1, O2 is perpendicular to CD. So basically, we want to show D is the, actually, wait. ABC and K, O1, O2. Yeah, so it's like we want to show those two intersect at a point. So that they would kind of be homothetic is what we want to show.
And the angle chase KO1, O2 is equal to half of angle EO1G.
KO1, O2 is half of angle EO1G.
Yes, because KO1D is half of EO1D and DO1, O2 is half of DO1G.
Yeah, I see it. Okay, so I wonder if that is almost enough to solve the problem. So KO1, O2 is half of angle EO1G, which we can write that in terms of EDG, right? And then, so once we know EDG, what does that tell us? EDG is ED, but do we know, yeah, we do know it's 90 plus EDB, right?
Yeah, once we write ED is equal to 90 plus EDB, then replace EDB by 90 minus EBD.
But how do we know that EDG, how do we know that angle MDG is 90?
Oh, maybe that's what we have to prove now.
Yeah, like if we could prove that, I think it would solve the problem, right? If we could prove that angle MDG is 90.
Oh.
Hakan.
For that, maybe proving that GO1M are collinear.
Yeah, so if we can show GO and an M are collinear, that would solve it.
Okay.
So yeah, let's see. Can we show angle GMD as O1MD? So GMD is GED. Well, GMD is half of, let's see. Yeah, if we can show GM passes through O1, then actually that would solve the problem very easily, right? Because then GN also passes through O2, and then the parallelism would be easy, I guess. So we could show GEM is 90 degrees. DO1G is 2 GMD. But I had something that I was thinking I just forgot. So if we could show angle GEM is 90, that would solve the problem. So we want to show angle GEK is 90. Oh, this looks like it might be the in-center X-center lemma or something. So I think D might be the circumcenter. Let me try something. No. But we want to show GEK is 90 degrees. So yes. And that's kind of like saying, yeah, this looks a lot. So yeah, we want to show like KEGF is cyclic. Yeah, I wonder what the circumcenter of KEGF is. Let's see. Looks like just some random point. So we know those are parallel, KO1, KO2. So I think it's true that KEGF is cyclic because EGF is EGD plus FGD, which is EMD plus FND, and that's 180 minus EKF. So yeah, we can show that that's cyclic, EKFG, and then how do we from there? Is there a way to show? So I think is AB and AC tangent to it? I think it might be. So where have we used that DB is equal to DC? I don't know if we've used that yet, but yeah, we have to use that fact somehow, I think. Whoops. What is H? I don't even know what point H is. Wait, now KEGF doesn't even look cyclical. Oh. KEGF. Yeah, so I can prove that's cyclic by an angle chase. But then how do I show angle KEG is 90? So So I have if I can show AEK is equal to EMB, I think that would work. Is that true? No. I want to show AEK equals GED. Yeah. We don't know GE equals GF. Is that true that GE equals GF? Huh, that is true. But KG bisects EF. And KG bisects EGF. How do we know that? So hold on. Yeah, I think I'm going to end it here just because it's been around 3 hours. But yeah, this is a lot of fun. I got a little stuck on a couple problems. But yeah, hopefully I'll take a look at them after and see if I can figure them out. But thanks everyone for participating. Have a good one.
Thanks, Michael.
Thank you. See you next time.